I am back again, putting the monkey to ride another animal. Monkeys are always happy to ride another fellow animals. I mean, if they could, they would ride the entire zoo. So, having forward, this will complement the first video about connecting microcontrollers to PLCs to give and extract data. So in this video I'm going to extract so give a word to the PLC and extract another word from the PLC back to the microcontroller and show it in the LED display. So I've shown everything is set for test. The buttons I have cut it off from a broken printer. I cut it off and soldered some wires to connect to the microcontroller, and the LED is connected to the microcontroller via E2C, and the microcontroller is connected to the PLC like in the previous video with 3 wires. 4 wires would be better, but I wanted to maintain the same connections, although I have to change the electronic circuit itself, but it's the same as in the previous video. And a big warning, this video will not cover every single technical aspect. This video will cover only the idea itself, to connecting microcontroller to the PLC via a simple ins and outs. Yeah. So I didn't do any political choice in respect to the microcontrollers. I mean, all of them are great. Especially the Texas Instruments ESP32 and STM32. They are really great. I mean, they are the best. I mean, and SP32 you would connect, and they have embedded wireless like Texas Instruments, and you could connect the PLC directly with your phone. I mean, using the microcontroller as a way, as an interface. So that would be great, but I chose the STM32 with a LED to show in the video how to give data to the PLC and receive it back and display it in the LED. And also STM32 has a intuitive programming interface, and flashing tools are also nice. I mean, you can flash through their tools or flash through UART. I mean, and also one big important thing for me, it's the programming environment from the microcontrollers work well with Linux, because I'm mostly work with Linux itself and not much with Windows. Now you can choose everyone else, but by STM32 you can program it at the high level C. You can, like I did in this video, and you can use it the FreeRTOS environment. It's really intuitive and is embedded in their programming interface. It's really nice. You can connect a USB to this microcontroller to extract data. You can connect a SD card. The programming environment software as already easy ways to do that, and you don't need to read all the data sheet. The programming environment will do part of the work for you you don't need to read all the data sheet from the microcontroller. You only need to know how to program it, and of course the FreeRTOS environment is also there in the and they have really nice. They embedded real nice in the programming environment from the STM32, the STM Cube. Yeah. That's why it's sort of intuitive. And having that way, it's easy for those who can program in C, find a way quick and implement their own algorithms. So what would the wise ass marketing genius would say?
I've swallowed enough microchips and shit them back out again, enough to make a fucking computer.
Yeah, at this level nothing is that simple. Even for actors at that level, it's not easy to think of. Different controller means that you have you need a different electronic to control it. In the previous video I had some sort of Arduino working at 5 volts, and this one is a 3.3 volts STM32. So we need some sensible outputs, and since I didn't have the push-pull, I made some changes there. I put the resistors, some resistors, and the transistors in that way, so you can trigger the MOSFET quicker and empty the capacitance from the MOSFET with the resistor to ground. Yeah, and I mean it's sort of a push-pull. It's like you push and pull with only one end. Yeah. And for this purpose it works great. I mean, it's not a perfect circuit. It has some problems, but for this case it will work fine, as it did. So I put some 1K resistors in series with a transistor. Yeah, because I wanted to really make a quick trigger to the MOSFET, to the base. But you can, I mean, we can use, or I could use 10K resistor, and having the transistor triggering the MOSFET this way, I only need some microamps to do that. So as I calculated, everything above 30 microamps. Microamps. So and you would achieve in the MOSFET gate 12 volts. That's the ideal to do some general purpose MOSFET will trigger at that voltage. So I used for the microcontroller an independent source. Yeah. A 3.3 independent source, and everything that passes through the PLC, I'd use a 24 volts voltage source, and I have used some trickery with the PLC output, because I needed to output between 3 and 4 volts. So I used some diodes and the LEDs to become that voltage. I mean, everyone knows that in theory every LED will cause a voltage drop from 0.7 volts. So just have to add two diodes. Yes, two diodes and a LED. The LED will usually drop independent by the color. It in my case it was green. It dropped circa 2.4 volts. So in general I add 3.84 volts and then output from the PLC going into the microcontroller input, and also having a LED that displaying me that the output was triggered. Not only the LED from the PLC itself, but only the LED outside. Yeah. So and this way I could spare the optocoupler. Yeah, like I wrote in the previous video, the professional ways to use the optocoupler. In this case, it would be also nice to use the optocoupler to connect to the microcontroller itself. But it's really safe. I mean, it's really safe for test, not for the professional ways. For test, it will be great. The voltage will not oscillate because yeah, it's simple. It's dodgy. Simple, but it works. So I think I'm going to introduce everything working in the really slow time, and make a video over the PLC programming and another video for the microcontroller programming, because this is getting too long already. Yeah. So let's introduce everything. The monkey is riding the dog, real happy. So there is the dodgy MOSFET set amplified with the transistors, and the dodgy two diodes and a LED to make the voltage for the microcontroller. And let's put this to work. Let's test this. I have made a menu. Here we go, with three words. They send 1, 2, and 3 values to the PLC. So the first, to extract one word contains the value stored, pre-stored there. The F00F, that's hexadecimal. So now going to go to the main monkey, and go to the menu and choose the second option to send the PLC. There we go. The LED output pulsing is giving the bits to read, and in the microcontroller, in the black pill itself, it's called black pill, is also a LED blinking, signalizing me that it's a 1 bit that the microcontroller is going to read. So and the second option was 010101. So it means 4 times the A in hexadecimal. And the third option is 4 zeros, 8 ones, and 4 zeros again. Previous stored in the PLC. Nothing of this is programmed in the microcontroller. I mean, the microcontroller holds these zeros and ones from the PLC. Yeah. But this is also clear in the programming, the PLC programming, and in the microcontroller programming that we are going to show further. So I just put a slow time just to show that in the real slow time. This is the microcontroller programming, but I'm going to explain that further. I think for now it's okay. I mean, yeah, seems like there's another animal in the jungle, and seems like a woodpecker. Yeah, that's one of disadvantage of having PLC output relay. Yeah, we cannot extrapolate in the switching time. It switch like crazy. Would it be better if it was transistored output and quicker and quieter? But yeah, unfortunately I have relay output, but it's also possible to do it. So we're going to see then how much we can get out of it.